Hi, everyone, and welcome to this episode of Crowder Beaker Solves. Today, we're continuing our series on gas law problems, and we're going to be looking at something called Charles law today. And you can see there's a prompt over here on your screen, and I'll read it, and then we'll talk about why it's Charles law. So here we go. Inside a balloon, and if you haven't noticed already, chemistry is often a series of word problems. You're supposed to imagine a scenario based on a word problem and some data that are presented there, and then you're supposed to make sense of what to do with it. And I'm trying to give you some direction on how to do that when it comes to gases. So inside the balloon store, pretend there's a store that just has balloons only, and the temperature is 20 degrees Celsius, and a balloon has a volume of 15 liters. So a nice, decent sized balloon. If the balloon is brought outside in winter when the temperature is minus 10 Celsius, what will the new temperature be? Maybe you've had that experience where you buy a balloon in the winter and you're walking to your car and suddenly the balloon kind of shrinks and it kind of looks sad and you wonder what happened to it. But then you warm it up again and it gets nice and happy again. And this is an example. If you're looking at the prompt, we have a temperature, we'll call that T1, a volume, we'll call that V1, a new temperature, T2, and then it asks for the new volume. So I have two V's and two T's being given to me and one is being asked for. So assuming you have some kind of notes or a chart that summarizes your gas laws, we're looking for something, not this one because this has pressures in it, pressures, so they all have pressures in it except this one. We don't have the number of moles though. We have this one, which includes volumes and temperatures. Jacques Charles was a scientist a long time ago who was a balloonist, and he noticed when he was making his balloons so he could fly around the countryside that heating up a sample of gas causes its volume to expand. And he also figured out that that was a proportion. So the volume goes proportional. We're going to write, so pressure and moles are constant. Sorry about that. So nothing is said about them, so I'm assuming they're constant. But Charles said that the volume of a gas is proportional to its temperature. Okay, so I'm going to put that down. Now, pause for a second. If you're writing this down, great. Thank you for doing that. But pause for a second because I got to show you something. Don't write anything down. If I just go ahead and plug this in, let's see, the volume is 15 at 20 degrees Celsius, and we're trying to find the new volume at minus 10 degrees Celsius. V2 is going to be, and forgive me, I haven't calculated this out already. All right, it'll be a negative 7.5 liters. Okay. Now, whenever you're doing problems, you want to get your answer, and then you have to perform a very important test, and that is the does this make sense test. And to me, this does not make sense because how can you have a volume that is negative? You either have something with a volume or you have no volume, in which case you have nothing. But it's really, I don't know if it's possible to go negative volumes on here. So keep your eyes out for this because it should be a reminder that we have to do something. There's a little catch to this. And that is your temperatures in gas laws have to be in kelvins. It has to be on the Kelvin temperature scale because the Kelvin temperature scale is an absolute temperature scale. And 0 Kelvin is the lowest temperature you can get. There's no negatives, and you build from there. So if you started at 0 Kelvin, theoretically, and the volume expanded to 100 Kelvin, it would expand. Then if you went to 200 Kelvin, it would actually double that volume. So it has to be in kelvins. So let's just take a moment and get rid of those. And in case you're wondering, the Kelvin temperature equals the degrees Celsius plus 273. If you want to get technical about it, 0.15, but lots of times you don't have to worry about the 0.15. So I'm going to add 273. This is going to get a little messy here for a second. 20 degrees plus 273 is actually 293 Kelvin. So we'll put a little sad face there because we don't like that answer. And minus 10 degrees Celsius plus 273 is 263. I'm just going to use whole numbers for this one. And I'm going to resolve my proportion. And I get a volume of V2 of 13.5 liters. So the temperature went down, but not really that drastically comparing on the temperature scale, the Kelvin scale. And so the volume dropped slightly to 13.5. And that makes sense to me. And I'll put a little happy face next to that one because that one makes a little more sense. All right, so just remember your temperatures in kelvins. So it is your turn. We will put another prompt up here. If a balloon is filled with nitrogen, has a volume of 5.6 liters at 10 degrees Celsius, what will its volume be at 50? Pretty common type of problem. Take a moment and pause the video and see if you can solve this one correctly. All right. Thank you for trying. And if you solved it correctly, you should have gotten a new volume of 6.4 liters, because at 5.6 at this temperature, we increase the temperature on the Kelvin scale. The volume goes up proportionally to 6.4. My calculator gave me a whole bunch more digits than that, but I'm only giving 2 because that's what I started with in that volume. Okay, so there you have it, a nice Charles law problem to get us off to a good start. If you have questions or suggestions of problems you'd like me to solve, you can send them to me. In the meantime, happy solving and have a great day.